All right, picking up where we left off here, we want to answer the following. Assume the height is normally distributed with a mean of 69 inches, standard deviation of 3. What's the probability that the man will be between 59 and 64 inches tall? So we can take our curve here. We've already put in the normal distribution command with our standard deviation and our mean. I want to know between 59 and 64, so I'm going to put in 59. I'm going to put in 64 for the max. Okay, if you want that in your notes, you should take a second to write that down. So min, what's that, 59. Max is at 64. And again, this outputs as a decimal. Okay, so this is going to give you 0.047. All right, so 0.047. So that's the probability that a man that is randomly selected will be between those heights. So it outputs a probability. I don't think I mentioned that in the last video, but it outputs a probability. We can convert that to a percentage. If you like thinking about percentages better, then the probability is a decimal, so it's 4.7%. Another way to think about that is 4.7% of men are between 59 and 64 inches tall. All right, so that covers the between example or situation. Let's find the probability a man will be less than, and instead of 64, because that is actually not that interesting, it turns out. Let's look at 70. Okay. So we want to know what's the probability that a randomly chosen man will be less than 70 inches. So when we take our curve here, we want less than, so we'll set the minimum to be infinity, and we'll set the maximum to be 70. And you can always check that the shading makes sense, because if you flip these around accidentally or something, the shading shouldn't make sense. This should be everything shaded to the left of 70, and it is. Okay? So that tells us that the probability is 0.631. Which is 63.1%. Right? So 63.1% of men are taller than 70 inches. Okay, let's do one more. You should try this one with on your own. So this is a new situation. Average student commute to school is average of 15 minutes. Standard deviation of 4 minutes, and then figure out the following. So you might pause the video and get that data in. I will type it in right now. So I have average of 15 and standard deviation of 4. Okay, so you can see right away that my graph is all, I'm not seeing the data that I need to see, so I'm going to just take and show you another way to get to the right spot. I'm going to go to let's see, our average is 15, so maybe we start this at 0 minute commute and then go up to, I don't know, 30 maybe. Let's see what that looks like. There we go. It's not too bad. Okay, so I got the mean and the standard deviation in there, and then I first want to know what's the probability that x, by the way, that's our random variable, which is the commute time. What's the probability that that's greater than 14? All right, well, to figure that out, we're going to take, in Desmos, we're going to put, since it's greater than, we're going to put our min at 14, and our max, we can just let that be infinity. So we just click off. Whoops. Check it. There we go. Okay. And so it tells us right there, you can see the shading makes sense then, right? Our average is in the middle, 14 is slightly to the left of it. The shaded area is everything greater than 14. And it tells us it's 0.5987, that'll round up to 0.6. So the probability is equal to 0.60 or 60%. Okay, again, this is the probability that the commute is greater than 14 minutes. Okay, so there's a 60% chance that a randomly chosen student will have a longer than 14-minute commute. All right, last one, between 5 and 17. And in Desmos, this is pretty straightforward. You just type in 5 for the min, 17 for the max, and you can see that shades the area there. All right, and it tells you that that is 68% of the data, or 0.685, so that's 0.685. Usually go to 3 decimals because that'll get you 1/10 of a percent if you times by 100, so 68.5%. So again, that means 68.5% of students have a commute that's between 5 and 17 minutes long. All right, and that wraps up normal distribution.